This is the United States Energy Association Power Sector Podcast. I'm your host, Herman K. Trabish. I've covered the power sector since 2006, and I currently report for Utility Dive. My guest today is Duke Energy Senior Vice President for Pricing and Customer Solutions, Lon Huber. Lon has led incentives at Duke that won agreement for the utility with both community solar advocates and rooftop solar advocates. But what brings him to the USEA Power Sector Podcast today is his more recent work on advancing transportation electrification. Lon, electric vehicles were under 1% of all light-duty vehicles on U.S. roads in 2022, but they were 7% of new vehicle sales. And Fortune Business Insights recently reported that the $28 billion value of 2021 of the 2021 U.S. EV market could more than quadruple to 137 billion in 2028. Some say the anticipated electricity demand from a potential 20-fold growth in EV chargers to meet policy objectives like the Biden administration's goal of making 50% of new vehicle sales electric by 2030 could threaten power system reliability. Without getting yet into managed charging, can you explain the difference between the capacities of the bulk transmission system and the distribution system, and how to distinguish future concerns about what the EVs are going to do to the grid from present concerns like charging clusters?
Sure. Well, I think you hit that last part on the clusters. It's location, 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 which is the difference between the distribution and the bulk system. In the bulk system, you have regular planning processes that take into account load growth, and so you're ensuring that you've got enough generation capacity there to overall meet those top hours of the year. Then you've got the distribution system where if you have a fleet that's concentrated in a certain area, and maybe there's a bunch of them. So like think around an airport, you've got a FedEx, Amazon, you've got them all electrifying. You've got a local distribution area capacity constraint. You have enough generation system-wide to cover it, but you've got that bottleneck, and you've got maybe a substation that you've got to upgrade to deliver what is essentially, when you think about some of the load, it's like placing a skyscraper at each one of these locations. So, going to a grid planner and saying, hey, I got to electrify, I got to have these DC fast chargers. Well, that's like putting the Empire State Building, right? Just boom, plopping one down, then plopping it next, 5 to 9 megawatts, these installations. So
it requires that much power.
It requires that much power in a concentrated little location. And so that's the challenge. And so, we have to get ahead of that and think of proactive grid planning to make sure that we as in all the stakeholders in the utility sector are in communication and having the right policies and regulations to make sure that we carry this preparation, this grid readiness out in the most cost-effective manner.
Yeah, that planning dimension is under-recognized, and I see it coming up more and more often in utility regulatory processes, calls and regulatory processes for more and more types of planning, more and more detailed planning.
Absolutely.
Yeah. More integrated planning.
Yep. And then you need the policies to encourage that investment there, and to get it ready, because it's much faster to do the upgrades all on the front end instead of, Hertz decides to electrify, we do an upgrade, then Enterprise, then we have to do another upgrade, right? It's more cost effective to do it all at once in preparation for sort of more mass electrification in a particular hyper local situation.
And we know it's coming. So there are things that you guys are doing at Duke, that regulators are doing to manage electricity demand from EVs at the distribution system level, to manage and be aware of these near-term and longer-term needs, like cluster charging and locational issues. So regulators in North Carolina are working on this. Regulators across the country are working on this. And one of the things they're talking about are passive and active charging rate designs and other strategies and programs that can sort of help control when EVs come on the system to charge. So tell us about that. Tell us, what is passive charging? What is passive managed charging? What is active managed charging? How much do we know about whether either of them is going to work to help control those loads that are coming at us? And I know Duke has some really interesting programs that are working on advancing the understanding of both kinds of managed charging.
Yeah.
Tell us about those.
Well, I can confidently say that both types work. Passive is relying on either behavioral or sort of static, set in advance schedules for charging or not charging. Active is far more dynamic. It could be shorter time periods as well, and it's not preset necessarily time conditions. And so you can sort of think of how they relate to just our previous conversation on bulk versus local. With bulk, there's a lot more certainty of when you think there'll be a peak. You have loss of load expectations and probabilities that say, hey, it'll be likely in the winter morning between these hours or in the summer afternoon between these hours. And 95, 80, 98% of the time, it'll fall within that range. So that's where that passive charging can really help on the bulk system. And there's a decent amount of capacity in a bulk system as long as you're away from those peak hours, right? So that's why there's not
give me an example of passive charging. Like, what would you use for that time period, that peak, when you know that there's going to be a load in that morning, that winter morning? There's going to be people are going to be running their electric heating systems and other electric appliances, and so there's going to be a big load peaking a high, and so what is a passive strategy to deal with that?
Yeah, so let's take one of our programs. We have an off-peak credit program. If the EV owner sets within their vehicle dashboard when to charge, most vehicles have this feature, and they'll set it, and there's a verification process that we use, and we also follow it with AMI disaggregation. But that's an example. We say, hey, winter mornings don't charge between 5 a.m. and 9 a.m., right? Make sure you enter that in. And then same thing for summer. That's a passive charging program. Again, there's a decent amount of generation capacity in the bulk system as long as you stay out of those peak hours, right? So that's why there's not that big of a concern with being able to handle the load from EVs, because you can move that around. Now, when it gets to the distribution system, the local side, that is harder to pin down on, and it varies by circuit. One circuit could be a 5 to 9 p.m. peak. Another one could be a morning peak. Some could be an afternoon, right? And so, and then it also just depends on what's happening on that particular circuit. So that's where that active managed charging comes in. And so that's an example. I'll give you an example of a program that we have, our EV subscription pilot, where it's a type of $24.99 all you can smart charge. And obviously there's programmatic caps, so it can't be exploited. But that is one where we will send a signal to the vehicle modem and to our partners on when to curtail some charging or to charge up, depending on what is going on in the local system at that time.
So in that case, the utility is being active. It's actually sending out a signal, actively sending a signal. In the other case, the utility is being essentially passive. It's just depending on a certain number of customers responding to the price signal that is there to not use their charging at that time. That's the difference,
price
right?
signal,
and both of those are going to work.
Price signal or programmatic carrots. Yeah.
Like what? What's a programmatic carrot?
Well, as long as you, just the off-peak credit program that I mentioned, as long as you set that, you will receive a bill credit. And so you have to be on a time of use rate. It mimics the same economics of a TOU rate, but they don't have to be beholden to price signals. It's a carrot approach. We have other ones where it's the TOU rate, which is a different approach.
Time of use.
Yeah.
The time of use rate. Now, you said that both of those kind of strategies work. Seems pretty obvious that the utility being active can make it work. But are you confident that customers, you don't need every customer to respond, even when uh, penetrations of EVs grow, you're still not going to need every customer to respond. You're just assuming, or you believe, or you have evidence that a certain number of customers will respond to help reduce that peak demand and prevent any kind of problems on the grid. Is that right?
Yeah, yeah, and again, it's beneficial to the customer. We're not asking for them to sacrifice, because when they set up their charging, there's economic benefits to that too, right? So they're better off. They've got a lower charging bill, and then the system's better off. And we've seen our programs, that off-peak credit program, that we were expecting 1,000 signups when we, rolled it out. We had 2,000 within that same time period. So they're popular. It's again very easy and seamless for the customer. A lot of this stuff is happening behind the scenes. So and then, of course, with price signals, you see households and businesses respond to price signals all the time when those prices are elevated or there's a critical peak pricing time. We've seen some really strong results on responding to those signals.
Okay, I want to get to this next question. We hear a lot about using EVs like the Ford F-150 Lightning for home backup power. That seems like a different kind of a situation. Is that, I mean, people will say, is that possible? Can you use your car to run your home? Duke has pilot programs. Can you use vehicles for home backup power? Is that being done now, or is that some future concept? And is it much different than home batteries where you store something in your battery at home, or is it the same situation where you have a car, you put the electricity in the battery, you take the electricity out of the battery, like Tesla Powerwalls have advertised?
Yeah, the concept is very similar. I would say we're still at early stages of this type of technology. It's not as simple as, hey, plug your truck into the wall. There's decent amount of equipment that it takes and software that you need to enable that to work seamlessly with the household. It also depends on the house. I mean, do you have two AC units, right? And so it's beginning stages. Certainly not a majority of EVs at this point don't have that capability. And again, the ones that do are in the early stages. But we have tested this. We have had success in backing up load and with vehicles. So we have executed on this, and we think there's a great deal of promise. But to have set realistic expectations, it's not as simple as just plugging it in, right? And it takes coordination, it takes advanced software to make it all work seamlessly.
How does the compensation work? I mean, does a customer reduce, is it sort of like solar net metering where the customer rolls back the meter if they are putting their own electricity onto the grid, or is it too early to know how that's all going to work
Well,
out? Is it going to take a whole lot of extra equipment on the, garage wall, inverters and, electrical boxes to make it all happen? Or is it something that you think is within practical reach right now?
well, one thing is the vehicle backup to the home. So that's when there's an outage. So that's just taking care of that particular situation. There's no credits or anything. That's a benefit that the homeowner gets from the vehicle. The concept that you've shifted to now is more of a demand response program, where when there isn't an outage, we could call on that vehicle to supply some energy to the home, or in some cases actually export to the grid. And so we have filed pilots around this, and we think that there's certainly some promise there, given the size of the batteries of these vehicles. It can provide a significant amount of demand response. And again, these are only like 2-4 hour max type of events. They're not going to be draining a vehicle's battery by any means. There's practical limits on how much can be exported. And so again, early stages though. Early stages, it takes a decent amount of equipment. The industry is working to try to streamline how much equipment you need and to get it integrated into different kits. And again, it goes back to software as well, to being able to do this in a way that's grid friendly, and follows all the safety protocols that we need for linemen that are out there working, online.
Right.
So So early stages, but very promising. But again, a lot more work needs to be done to make it seamless for the customer, to get the technology there, and then the compensation models, to your point,
Okay.
have to be worked out. And we see it more as a programmatic compensation, not a
Per
more
kilowatt hour, cents per
yeah,
kilowatt
yeah.
hour.
We want to make it
Okay.
simple to the customer, right? We don't want them to have to get out a calculator to figure out what they're going to get.
Mhm.
We'll say, hey, if you enable this functionality, we will give you X dollars per month off, right? Or we will work with, and this is what we proposed and that was approved in North Carolina, where we will actually just reduce the lease payment. We'll work with Ford, reduce the lease payment of the car in exchange for being part of this program. So that reduces a lot of complexity.
Interesting. Okay. We're almost out of time. We really have just a few seconds left. When do you think these more early stage technologies are going to become part of the mainstream? As common as we see people putting rooftop solar on their house all the time, we see solar projects being built out in open spaces and wind projects. When do you think this is going to be just that common?
Well, in terms of those original programs that we talked about, they're becoming more and more common. We have actually 17 active programs out there, 6 pending across our footprint. So they're becoming, out managed charging solutions are out there. Charger solutions are out there where we own and operate these chargers to make sure they have high reliability and top standards. In terms of some of the new things of vehicle to home and vehicle to grid, I still think we're 3 to 5 years away from it being the majority of EVs out there being capable of it, and then maybe even longer to get a majority of EV customers to adopt the technology, because it's an investment into the home. To the extent that they're moving around, right? It doesn't follow them, and
Yeah,
so there's a little bit of a
right.
reluctance there to put that type of investment into the home.
That's going to do it for today's USEA Power Sector podcast. Thanks, Lon. I really appreciate your brilliant input. I must say, nothing less. I've always gotten exactly that from you. But also thanks to our viewers for checking us out. And everybody who sees this, be sure to tell everybody you know about our quest to find solutions for the transitioning electricity system.